Hello, this is Mr. Brooks, and welcome to Lesson 5.5, Inequalities in Triangles. In this lesson, we're going to use inequalities involving angles of triangles, and we're going to use inequalities involving sides of triangles. First, we need to talk about the comparison property of inequality, which simply states, if you had a pitcher of orange juice, and you poured part of the pitcher into each glass, you can be sure that the amount in each glass is less than the amount you had in the original pitcher. Now remember that you have to pour some orange juice into each glass. You can't just pour it all into one glass, and of course it would be equal to the original amount. But if you pour part of the orange juice, even one drop, into one glass, and you put the entire pitcher into the two glasses, the amount in each glass must be less than the amount you had in the original pitcher. Now we are going to use this comparison property of inequality, and we are going to combine it with the triangle exterior angle theorem. Now remember, the triangle exterior angle theorem said the exterior angle of a triangle equals the sum of the two remote interior angles. So for this one, angle 1 would equal the measure of angle 2 plus the measure of angle 3. But now we're going to talk about the corollary to the triangle exterior angle theorem, which would state that, remember, a corollary is an extension to a theorem. We're going to put the comparison property of inequality together with the triangle exterior angle theorem and come up with, well, if the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3, then the measure of angle 2 has to be less than the measure of angle 1, and the measure of angle 3 has to be less than the measure of angle 1. Each of the two interior angles have to be less than the exterior angle. In example 1, we are asked to try to figure out why the measure of angle 2 is greater than the measure of angle 3. Please pause the video while you try to figure this out. The triangle exterior angle theorem tells us the exterior angle is equal to the sum of the two remote interior angles. So the measure of angle 1 has to equal the measure of angle 3 plus the measure of angle 4. So the measure of angle 1 has to be greater than the measure of angle 3, and the measure of angle 1 has to be greater than the measure of angle 4. So both 1 is bigger than 3 and 4. And if you remember, angle 1 was congruent to angle 2. So angle 2 has to be, measure of angle 2 has to be greater than, well, measure of angle 1 was equal to the measure of angle 2, so measure of angle 2 must be greater than the measure of angle 3. Quick check number 1 asks us why the measure of angle OTY is greater than the measure of angle 3. Please pause the video while you try to figure this out. Well, just a minute ago, we said the measure of angle 2 is greater than the measure of angle 3. So, obviously, the measure of angle OTY has to be greater than the measure of angle 3, because a measure of angle OTY is 2 plus 4. Now we are going to talk about sides of a triangle. Theorem 510 states, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So, of course, the smallest angle would lie opposite the shorter side as well. Now let's see how this applies to example 2. If you want to put benches in the largest two corners of this triangular deck, which two corners would you put the benches in? Of course, you can't take a giant protractor out and measure the angles in each corner. How would you figure out? But you can take a tape measure out and measure the length of each edge of the deck. And you can see the edges are 27 feet, 21 feet, and 18 feet. So which corner would you put your two benches in? A, B, or C? Please pause the video while you try to figure this out. Hopefully you would agree. You would try to put the benches in corners B and C. Angle A is opposite the shortest side, so that's going to be the smallest corner. B and C are opposite the two longer sides, so those would be the largest corners. Quick check number 2 asks you to put the corners in order from least to greatest. Please pause the video while you try to figure this out. We already said your smallest corner would be angle A. The next smallest corner would be opposite the 21-foot side, which would be corner C or angle C, and then your biggest corner would be angle B. Our next theorem states that if two angles of a triangle are not congruent, then the longer side lies opposite the largest angle, which is just the opposite of what we said. If the largest side is opposite the largest angle, then the largest angle is going to be opposite the longest side. Now let's see if we can apply this to example 3. It asks you to put the sides in order from shortest to longest. Please pause the video while you try to figure this out. First, you're going to have to get the measure of angle T. So you could add 58 and 62 up and subtract that from 180, and you get the measure of angle T to be 60 degrees. Now we can figure out the shortest side is opposite the smallest angle, so TV is going to be the shortest side because it's opposite the 58 degree angle. UV will be the next longest side because it's opposite the 60 degree angle, and the longest side of the triangle would then of course have to be TU because it's opposite the biggest angle, which is 62 degrees. Now let's try quick check number 3. Try to get the order of the three sides of this triangle from shortest to longest. Please pause the video while you try to figure this out. First, you need to get the measure of angle Y. So you're going to add up 40 and 60, subtract it from 180. So hopefully you'll get the measure of angle Y to be 80 degrees. Then you can put the sides in order from least to greatest, or shortest to longest. So YZ is going to be the smallest one. Next is going to be opposite the 60 degree angle, which would be XY. And last is going to be XZ, which is opposite the biggest angle, which is 80. The last concept we need to discuss in Chapter 5 is triangle inequality theorem. First, I would ask you the question, if I gave you 3 sticks, doesn't matter how long they are, could you always make a triangle out of them? Please pause the video while you try to figure this out. As you can see, if I gave you a stick 3 centimeters and 3 centimeters and 5 centimeters, you could make a triangle. But if I gave you a 2 centimeter stick, a 2 centimeter stick, and a 6 centimeter stick, you could not make a triangle because the 2's would not reach each other because the 6 is too long, which leads us to triangle inequality theorem that states the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. The 2 smaller sides must add up to be longer than the biggest side. So in example 4, we are asked, if I gave you sides of length 3, 7, and 8, could you make a triangle? So you take the 2 smaller sides, the 3 plus 7, and since that equals 10, which is greater than 8, yes, you could make a triangle. The next one, how about a 3, 6, and a 10? 3 plus 6 is 9, which is less than 10. So the 3 and the 6 would not reach each other. You could not make a triangle. Again, you have to add up the 2 smaller sides and see if that is more than the longest side. Cannot be equal because then the 2 sides would lay right on top of one another. It has to be greater than the longest side. Now let's try quick check number 4. Please pause the video and try to see if you can make a triangle out of these 3 lengths. Hopefully you decided since 2 plus 7 equals 9, the 2 and the 7 would lay right on top of the 9, and so you would not have a triangle. But in this case, 4 plus 6 equals 10, which is greater than 9, and so you would have a triangle. The last type of problem you need to know how to do is if I give you 2 sides of a triangle, what are the possibilities for the third side? The way you're going to do this is if the 2 of the sides have lengths 8 and 10, first you're going to subtract the 2 numbers. You're going to go 10 minus 8, of course you get 2, then you're going to do 10 plus 8 and get 18. So the third side has to be greater than 2, has to be greater than 2, and the third side would have to be less less than 18. It couldn't equal 18 because the 8 and the 10 would lay right on top of it. Could it be 17.9999 centimeters? Yes, it could. Again, it could not be 2 because the 8 and the 2 would lay right on top of the 10. Could it be 2.0001 centimeters? Yes, it could. Anything greater than 2, but not equal to 2. Anything less than 18. So the possibilities for the third side would be x has to be greater than 2, and it has to be less than 18. Or you could write it like this. Either one of those are possibilities for the third side. Last is quick check number 5. If you have two sides of length 3 and 12, what are the possibilities for the third side? Please pause the video while you try to figure this out. Well, as we did in the last example, we're going to take 12 and subtract 3 and get 9. And then we're going to take 12 and add 3 and get 15. So the possibilities of the third side is it has to be greater than 9 and less than 15. As I said, you could also write that like this. Cannot equal 9, has to be greater than 9, like 9.001 would work. And it would 14.9999 would work, but 15 would not work and 9 would not work. Again, greater than 9 and less than 15. This concludes lesson 5.5.